So good morning everyone and welcome to this lecture. Today is the first day of motion in 2D and I'm planning to wind it up by the end of this week. Let's see if we can do this. Motion in two dimension. Now what is meant by motion in two dimension? We also call it in a better way motion in a plane. So what is going to happen is now bodies are going to move in a plane. When I say plane, what do I move by a plane is the surface of your notebook that you are writing. When your pen is moving on that notebook, it's moving on a surface. When you're writing on a wall, that is your chalk or your pen or your marker is moving on a surface. A surface, a plane is a two-dimensional thing. When something moves on a plane, when something moves on a flat road, horizontal road, that is motion in two dimension or motion in a plane. Why do we call it motion in two dimension? Because only two coordinates in space are changing with time, the x coordinate as well as the y coordinate. Do we understand this? Yes or no? Have we done this motion in two dimension before? You must realize that most of the question that we did in 1D were actually of 2D, whether it was motion of particle moving in a circle, or we had given many examples of finding out the distance and displacement. Sometimes the particle was moving like this, then it started to move like this. Those all were not questions of motion in 1D, but they were actually questions of motion in 2D. Yes or no? Even then, let us first revise once more the equations of motion in 2D. So let us first write equations of motion once more so that if we have any doubt that gets clear. Equation of motion, now remember, almost 99% of the question that are going to happen in this chapter will be from constant acceleration. So the acceleration will remain constant. So first of all, let's just write the equation of motion for constant acceleration for a 2D motion or motion in a plane. What would be the first set of equation? The first set of equation we will write will be in the form of vector equation. So how will the vector equation look like for constant acceleration? What is the first equation for constant acceleration in vector form for motion in 2D? Yes, what will be the first equation? Anyone? No one knows it? I know that you know it. So tell me what would be that equation?
B vector is equal to U vector plus AT vectors.
That is correct. We can't change the basic equation because the basic equation still remains same. We can't change it. They were vector equation. They were valid for 1D, 2D, 3D, but they were only valid for constant acceleration. Well done. What about equation number 2? Delta R displacement will be equal to U vector times T plus half A vector times T square. Yes or no? Do you understand this? Equation number 3, it looks a lot difficult in vector form. Then in the scalar form, it is u dot u plus 2 times a dot your displacement. And the fourth equation was, we had written for displacement in the nth second, and the equation was u plus a by 2 vector times 2n minus 1. 2n minus 1. These were the equations of motion, but they were only valid when the acceleration was constant. This a acceleration, this a, this a, this a, this was constant acceleration. And what did I mean by constant acceleration? When the acceleration is constant, it remains same. your average acceleration and your instantaneous acceleration both are equal. Do we remember this? Do we understand this? Okay, I repeated the same thing a lot number of times or many times so that even if you have any doubt, that doubt stands clear. I'll give you 1 minute to note it down.
Done, sir.
Okay, I guess everyone has done this. Now, what I'll do is I will give you a problem without telling you anything because I've already told you so many things about motion in 1D or 2D that you should be able to solve this problem. So we straight away move on to problem. Question number 1. A particle has a velocity 2I minus 3j and has an acceleration 3I plus 2j. Find the velocity and displacement after 2 seconds. After 2 seconds, what would be the velocity and what would be the displacement? I hope you have understood the question and you have understood how it has to be done. Give you 2 minutes more to think about it. Let's see who gets me the answer. Yes, do you have any answers from anyone? Or shall I do it? Shall I do it? Okay, so how are we supposed to do this? It is pretty simple. I have to find out the velocity and displacement, and the time that is given to me is 2 seconds. How do I find it out? I apply the formula V is equal to U plus AT. That will give me the velocity after 2 seconds. So what do I do? Velocity after 2 seconds will be initial velocity is 2I minus 3J. 2I minus 3J, that is the initial velocity, plus acceleration is 3I plus 2J multiplied by time. Time is 2 seconds. So what do I have? 4I minus 3J. Oh, sorry. What I'm writing? Why am I writing 4I? 2I minus 3J plus 6I plus 4J. I add and I get the answer 8I plus J. That is my velocity after 2 seconds. Anyone got this answer? Someone at the back got this answer. What about the others? What problems are you facing? Is it so difficult to understand, beta? Multiply and add. Is it difficult? Please tell me what you did not understand, beta. Any
It's
confusion?
not difficult, sir.
Okay. Don't get confused with simple things. Remember, beta, I always tell you, all questions that are going to come are going to be simple ones. But if we get terrified with them, well, then everything will scare us. How do I get the displacement? Ut plus half AT square. That is my displacement. Just put the values, get the answer, and stay happy. U is initial velocity 2I minus 3J. Time is given as 2 seconds, so multiplied by 2 plus half. Acceleration is given as 3I plus 2J into T square, which is 2 square. You can simply calculate it very simply. This 2 and 1, 2 will get cancelled. So what will be my displacement equal to? Here it will be 4I. There it will be 6I. So I think it will be equal to 10I
Minus 2J caps.
minus 2J cap. That is very simple. And it cannot get simpler than this. So, as you can see, nothing has changed. The concept still remains same. The same equations are still valid. We are again applying the same equation in the same way. Nothing changes here. Do we understand this? Nothing changes here. Same thing. Okay. Now, this was a question which had constant acceleration. Now, I can put this question in a different way. I guess you have not still done integration. Yes or no? You have not done integration, but you have done differentiation, right? Okay.
Yes, sir.
Okay. So let us write the question in a different way. Let us solve this question. Remember, whether it is a question of 1D, 2D, or 3D, or many Ds, the concept remains same. The position of a particle is given by r vector is equal to 2ti minus 3t square j. find the velocity and acceleration at, let us say, 2 seconds. The position of a particle is given by something, something. And I think we have done a similar question in the first chapter also. This is just to tell you, give you the confidence that nothing has changed. Everything still remains same. Whatever we have done in chapter number 1, why we have taken so much time in chapter number 1 is because chapter number 1 is the basic of everything. And every definition that is going to come now will come from chapter number 1. So I'll give you 2 minutes to do this.
Sir, velocity is 2 I cap minus 12 J cap, sir.
2 I cap minus
12 J cap.
L. What is L?
Sir, A is minus 6 J cap.
A is correct. A is correct, but your V is not correct. Okay. Let me do it. How do I get velocity? Velocity is still the derivative of position vector. Yes or no? So I just differentiate this. I differentiate this 2t. 2 comes out. Derivative of t is 1. So this is simply equal to 2 I hat. Yes or no? This minus sign still remains. Now I differentiate this one. 3t square. 3 comes out. Derivative of t square is 2t.
60 J caps.
Yes, you said the 6L, so I was confused. 6t j hat. Do you understand this? I also told you that this is known as velocity x component and this is known as the y component of velocity. Yes or no? Because we will be needing this x and y component very soon. Just now after this question. Okay, this was your acceleration and now let us, this was your velocity. Now let us talk about the acceleration. Your acceleration is the derivative of velocity, dv by dt. I differentiate this once more. If I differentiate this, derivative of 2 would be 0. So let us forget about this. Then let us move on and differentiate this. 6t, 6 come out, derivative of t is 1. So I get minus 6g. As you can see, life still remains same. Now, we were asked to find out velocity and acceleration at 2 seconds. Remember, what we have found out is velocity and acceleration as a function of time. How do I find the value at 2 seconds? So what do? I put the value of t as 2 seconds and I will call that velocity as instantaneous velocity at 2 seconds. So what do? I put the value of t as 2. So it will become 2I because there is no t here. I can't put it. Minus 12j. That is the velocity at 2 seconds. Do we understand this? Yes or no? That is the velocity at 2 seconds. How do I find the acceleration at 2 seconds? I again have to put the value of t as 2, but as I can see, there is no place where I can put it. So acceleration remains same. That means this is a case of which type of acceleration?
Uniform acceleration.
Uniform acceleration, constant acceleration. Acceleration does not change with time. Instantaneous value at all places is same. And this instantaneous value is also equal to your average value. This is again a case of uniform acceleration. Do we understand this? Yes or no? I hope everyone has noted this down. I'll give you a minute to note it down. Once you're done, please let me know. Girls have done this. Everyone has done this. The other class, I don't know what's happening with them. I hope everything is fine in this universe. Now, as we have done the problem here, we can obviously write all the problems in the form of vectors and then we can do them. But sometimes writing the question in the form of vectors may look very tedious, may be time consuming as well. So what we do most of the times, that instead of writing the equation in vectors, we will write the equation in scalars. But if we write the equation in scalars, the problem is 2. We can only write equation along one axis. That is problem number 1. Problem number 2 is we have to use plus minus for sign convention. So we can do that and we can write different equation along different axes. So one axis would be x-axis and the other axis would be
Y-axis.
y-axis. So I can write the equation. If I don't want to write it in terms of vectors, then I have this option of using the x-axis and the y-axis syndrome. What is the first equation that I can write along x-axis? So I write it like this now. Vx is equal to ux plus ax into t. So that I remember that this equation is only meant to survive on the x-axis. What would be equation number 2 then? Displacement along x, let us not call it so complicated. Let us just call it as x. X will be equal to, which is the position on the x-axis, will be equal to ux times t plus half ax times t square. Do we understand this or this is getting too complicated? No, it is the same equation, but just I put x so that I remember that this is equation along x. The third equation will be vx component ka square will be the initial component ka square plus 2 times acceleration along x multiplied by x. The fourth equation is displacement in the nth second would be equal to ux plus ax by 2n minus 1. But remember, whenever I'm using any sign convention, any equation like this, I have to use a sign convention. The sign convention that we use is this side is positive and anything along this side is negative. Do we understand this? Yes or no? No, yes. Similarly, you can write equation along y-axis. What will be the first equation along y-axis? Vy will be equal to uy.
Plus AYT.
The second equation will be
Y is equal to UYT plus half AYT square.
well done. That means these equations are getting into our heads. Number 3.
Vy square is equal to UY square plus 2AY into Y's.
Vy square is equal to uy square plus 2 times ay multiplied by y. Fourth, displacement
Yn is equal to UY plus AY by 2 into UN minus 1.
But remember, whenever we are using this sign, this type of equation, we have a sign convention. Positive, anything, any vector directed upwards is positive. Any vector directed downwards is negative. The only difference between this motion and the previous motion was that in the previous motion we only had to make one equation, whether it was equation along x-axis or y-axis. Here we have to make two equations. That does not make any difference in the eventual analysis. I hope we understand this. I'll give you a minute to note this down.
Done, sir.
Anyone got this? Okay. Moving ahead, I'll just frame a question and let us see if you can handle this. The x coordinate of a particle is given as this 2t square, and the y coordinate of the particle is given as t cube. You have to find, I hope you understand the meaning of symbols. V vector, A vector, S. What is S?
Displacements.
S is not displacement. Speed. And simply A. What is simply A? This is acceleration. Then what is this? Magnitude of acceleration. Remember magnitude of acceleration? This speed is instantaneous speed, which is the magnitude of this velocity. Do we understand this? Okay. Now I put this equation in this form. Let us see if you can do it in this form. Remember, nothing changes. Everything remains same. Give you 2 minutes to do this.
Sir, V vector is 4t I cap plus 3t square j cap, sir.
Okay, what about acceleration and the
4 I
magnitude?
cap plus 60 j cap, sir.
Okay, what about speed and magnitude of acceleration? It's pretty simple. From wherever you see it, I'll give you 1 more minute to be confident. Remember, it's all about confidence that you get. You can actually see the same exam in the paper that you have done, but if you're not confident enough, and the confidence, the only way you are going to get confidence is when you try the question yourself. If I solve it for you, You will only copy it. Copying cannot get you confidence, but only give you happiness. Oh, I understand this. That is not confidence, that is happiness. And this happiness may not last forever. Happiness is a instantaneous thing. You get happiness, an instantaneous thing. Confidence is what you carry forward. Happiness is not something that you can carry forward. I hope you understand what I'm saying. The more you practice, my dear friends, there's only one way you can clear JEE, and that is by practice. And I probably would have told you my mantra, my trick of getting into an IIT or clearing a JEE. You just practice. Do 40 questions a day for each subject, and no one in this universe can stop your selection. 40 questions a day. 40 correct questions a day. To get those 40 correct questions, you might have to do 60, you might have to do 80, you might have to do 100. If you have to do 100, that means your success is only 40%. But then each day, that 100 will reduce to 80, your success ratio will become 50%. Then that 80 will get to 60, your success ratio becomes 2 by 3. Then it becomes 50, 4 by 5. Oh, 50. Out of 50 questions, if you can do 40 questions every day, no one in this universe is going to stop your selection into an IIT. Okay, how to do this now? Let me show you both the ways side by side so that you understand that nothing has changed. So x is 2t square, yes or no? If I differentiate this x, I will get vx. Do we understand this? I can write it like this. Vx, velocity along x, is the derivative of x. So I can write it as 4t. Yes or no? Can I have raise hands from everyone that we understand this? So I'm just solving it. Yes. Hi. Okay. So I'm just solving it as x-axis. Now, if I differentiate it once more, 4t, 4 comes out, derivative of t. This is derivative of vx with respect to t. So I get 4 here. Now I can make one more equation along y-axis. Y is equal to t cube. If I differentiate this y, I will get vy. Vy will be dy by dt. And differentiate this, 3t square. That is vy. I differentiate this once more. I get ay, which is derivative of vy with respect to time. Nothing has changed. I am just putting y just to make sure that, this is along y-axis. So this becomes 60. Now, I have vx, I have vy. I have both the things with me. Now I can write the velocity vector-wise. Velocity vector-wise will be 4ti plus 3t square j. Do we understand this? I can find out the magnitude of this velocity, and the magnitude of this velocity, instantaneous velocity, is known as speed. What is the magnitude of this velocity? Under root of 4t square, which is 16t square. Do we get this? Plus 3t ka whole square. 3t ka whole square is 9t raised to the power 4. This is the magnitude of velocity. Everyone is getting this, yes or no? Let us write the acceleration in vector form, my dear friends. Ax is there, ay is there. I just have to write it with I and j. So I will just do the needful. So it will be 4i plus 60 times j. If now someone asks me, okay, tell me the magnitude of acceleration, don't worry. Write acceleration, write this symbol. It will be under root of x square plus y square. 4 square is 16 plus 60 square is 36t square. Do we understand this? Now, you could have done this way, or you could have done this way. So straight away you could have written the r vector, the position vector. See, you know x coordinate, you know y coordinate. So straight away you can have written r coordinate. r vector will become your 2t square I plus t cube j. You could have written it this way. Doesn't matter, you are doing the same thing in different ways. Now I differentiate this with time, I will get velocity. And if you differentiate this with time, you will get the same thing that you got there, 4ti plus 3t square j. Nothing will change, everything will remain same. I can differentiate this once more and I will end up with my acceleration in the vector form, my dear friends, 4i plus 6tj. So the fact of the matter remains same. It does not change. Now it depends on you how you want to do it. If you think that x and y axis wala method is better, you can use that with sign convention. If you think that the vector wala method is better, you can use that vector wala method. The only good thing is that x and y both are together, but then the thing becomes long, because if you have bigger x, it will be bigger y probably, then the r vector becomes very large to write. And you have to write I and j always, I and j. If you forget to write I and j, then everything goes here and there. So do we understand this, yes or no? Okay, since I have come here and I did not plan to do this right now, but since I have given you this question, from this question comes the next thing that I should now come, which is known as equation of trajectory. Equation of trajectory. I normally do it after I am done with the projectile part, but since I've just given you this question, there is point that I can make here, and probably you can understand this equation of trajectory. Now, what do you mean by trajectory? What do you mean by trajectory? Anyone? Trajectory is an English word. Trajectory. Trajectory is an English word. What do you mean by trajectory? Trajectory simply means the path that the particle is following. For example, if something is moving in a straight line, its trajectory is a straight line. The path that is following is a straight line. If something is moving in a circular path, circular motion, its trajectory is circular. That is the path that it follows. We are going to see one more type of path in this chapter, which will be like this. This would be a parabola. This parabola is nothing but, again, it is a path which is followed by the body. These all are trajectories. Now, as soon as we talk about trajectories and we are talking about a two-dimensional thing, this trajectory or this path is in 2 dimensions. So it will have, at any point, it will have some value of x and it will have some value of y. See, at any point, if you take, it will have some value of x and it will have some value of y. Do we understand this? Now, to know the equation, you must be knowing the equation of a straight line. The equation of a straight line is y is equal to mx plus c. Yes or no? You must be knowing the equation of a circle. The general equation of a circle, if I remember correctly, is x minus h, the whole square, plus y minus k, the whole square, is equal to r square. Am I correct? That is the equation of a circle. A parabola also has an equation. Y square is equal to 4ax. Now, when you look at all these equations, this basically tells us how we can draw this, or basically how we can draw the trajectory, or basically how we can draw the figure. These equations are known as equations of the path or equations of the trajectory, because right now we are probably not dealing them as mathematical figures. They are definitely mathematical figures, but we are taking them as paths which are followed by a body. So we call them equation of trajectories. Now, whenever we see an equation of trajectory, what is the one thing that we see? We see either y or x as a function of the other. So either I see y as a function of x or I see x as a function of y, because if I know y as a function of x or I know x as a function of y, I can plot their graphs. When I plot their graphs, I get their figure that they are making, I get which equation they are following, and I get their equation of trajectory. So equation of trajectory for any particle which is moving is nothing but we have to write x as a function of y or y as a function of x. Do we understand this? That simply becomes the equation of trajectory for that particular path that that particular particle may be following. Do we understand this? I'll give you 1 minute to note this down if you want to note it.
Done, sir.
Done, everyone? Okay. Let us go back to the previous question. And this is the previous question that I had. What do you see in this previous question is x is given as 2t square and y is given as t cube. So let me again write the same question. X is what? 2t square, I think. And y is t cube. Write or find the equation of trajectory. That is the question. And if you can do it on your own, I would be pretty happy. X is given as 2t square, y is given as t cube. Can you find the equation of trajectory of this particle? This particle is moving in the xy plane. It will be following certain path. Can you find out that path? If you find this is difficult, I'll probably give you a simpler one. I don't think that's difficult. Remember, if you understand the concept, rest is all maths. Physics only makes us understand the concept. You have to solve the question in maths. I've already told you the concept. Solving it is just a part of maths. I'll give you 2 minutes to do it.
T6 is equal to 80 square, sir.
What beta?
T power 6 is equal to 880 squares.
Okay. Does it look like this? Which I just told you. Does your answer look like this? Does your answer look like this? If your answer look like this, that is correct. Does it look like this? What have you done? Tell me.
Sir, I substituted in y square is equal to 4ax, sir.
Why? Just like that. What has this question got to do with that question? Think about it. Think about it. It's a question of maths. It's not a question of physics at all. The trajectory or the path is basically maths. You have to find the equation of trajectory, nothing else. Okay, so we will continue with this class. In the next one, I think your sir has joined, and we can continue with this question in the next class. Meanwhile, think about it. Whenever I talk about the equation of trajectory, I am talking about y as a function of x or x as a function of y. How do you get y as a function of x and x as a function of y? It's pretty simple. And I think you would be able to sort this out. Okay, so I'll see you in the next class. And try this question and try to give the answer for this. You will come across this question if and sir will tell you in parabola. Call it parametric form, I think, for parabola and all these things. There also, this is not obviously equation of a parabola, but you will come across certain equations in that chapter as well. Okay, then I'll see you in the next class. Take care and have a nice day. Any doubts, you can always come up to me. Bye bye, bacha.
Thank you, sir.
Bye.